All right, so we're going to shift gears a little bit here and talk about accuracy and precision and how to measure and record data. Because if you want to be able to use your data to draw a conclusion, it needs to be good data, right? So special care needs to be made to take precise measurements and be accurate in your measurements. You also need to take care to record your data in an appropriate manner. So at the end of this lesson, you should be able to define accuracy and precision and determine whether a data set is accurate and or precise. So some questions that you will need to answer in your summary at the end is, how is accuracy different from precision? And what determines the accuracy of a measurement? And what determines the precision? You will also need to be able to look at a data set and tell if it is precise and or accurate. So some measurements have an accepted value associated with them. If you are close to this measurement, then you have an accurate measurement. So really, you are looking at how close you are to the right answer. So take the bullseye target here. The right answer, or the place we are typically aiming for, is going to be in the center of the target. If we hit that spot, we have an accurate shot. This comes down to the person doing the measuring, or in this case, the shooting. Some people are better at hitting the bullseye than others. It is the same with taking data. It takes practice to become good at both of those things, but accurate measurements are important in order to have data that we can use to draw a good conclusion. Precision is a measure of how close your measurements are to each other. If you were to take a couple more shots at the target and hit the center again, not only would your shots be considered accurate, they would be considered precise since they are all close to each other. Now, what if you took 3 shots and all 3 were in a similar location, but not near the bullseye? What would you say about your accuracy and precision? Here we would be precise because all of the shots are grouped together. We would not say that they are accurate, however, because they are not where we were aiming. How could you explain a situation like this? Something like this indicates that there is something consistently wrong with our measurements. So what about this last target? None of the shots hit the bullseye, so we would not be able to say that they are accurate. And none of the shots are near each other either, so we would also not say that they are precise. So in this situation, the shots are not accurate and they are not precise. So let's look at a few graphs to see if we can visualize this a little better with data. This first graph looks great. A nice straight trend of our data that isn't too far off from our best fit line. The intercept goes through 0, 0, just like we would expect it to on this particular graph. So this graph shows data that is both precise and accurate. The second graph is all over the place. We can draw a best fit line, but that isn't really what it is. Only a couple of data points are anywhere near where we are trying to define as our general trend. So this graph would be considered not accurate and not precise. Now this last graph, at first glance, doesn't look too bad. All of the data points form a general trend, and we can draw a best fit line that appears to give us a nice relationship between the variables. If we look closer, however, we notice that the y-intercept is not at the origin. Should it be? Well, if we have a diameter of 0 centimeters, we don't have a circle. So how can we have a circumference of, well, anything? Since our data closely follows the best fit line, we can say that we are pretty precise in our measurements, but at the same time, we can't say that we are accurate. Those measurements are not correct. They are all off, but they are all off by the same amount. So we were consistent in our wrongly measured data. This is the graph we get a lot of times when we start measuring from the end of the ruler instead of the 0 mark. So this data, while precise, is not accurate. So let's look at these measurements here. In our first example, we took some measurements. We measured 78.1 milliliters, 43.9 milliliters, and 2 milliliters. Those were the measurements of the same thing. The correct volume should be 100 milliliters. So is this data accurate, precise, both, or neither? In our second example, we have 68.1, 68.2, and 68.0. The accepted value is 78.1. So is this data accurate, precise, both, or neither? In our third example, 98.0, 98.2, and 97.9, when we should have gotten 100. Is this accurate, precise, both, or neither? And then our last set of data, 72, 60.3, 68.1, when it should have been 100. Is it accurate, precise, both, or neither? So pause for a minute and look at that data and think about whether it is accurate, precise, both, or neither. So your first one, it would be neither. Those numbers are not close together, and they are not anywhere near the answer that we should have gotten. So this is not accurate data. This is not precise data. This is not data we can use either. In our second example, we have a pretty nice grouping there. We have 68.1, 68.2, and 68.0. That is really good, except for the fact that it is not what we expected it to be. So we have precise data, but we do not have accurate data. In our third example, we have 98.0, 98.2, 97.9, when it should be 100. So those numbers are all really close together, so that is precise data. And it's pretty darn close to 100. You could argue, depending on your skill level and depending on what you're needing to do, you could argue that those numbers are way too far away from 100 milliliters. But if you give me 98.2 milliliters and it's supposed to be 100, I'm going to count it. So this would be both accurate and precise data. And then in our last example, we have 72.0, 60.3, and 68.1. That's a lot closer than our first example, but it's still really not grouped together very well. So that is not precise. And we were looking for 100, so that's too far off. So this is neither accurate nor precise data. Okay. All right. Can you define accuracy and precision? And can you look at a data set and determine whether it is accurate and or precise? Don't forget these summary questions. Distinguish between accuracy and precision. Know how accurate measurements come about and how precision measurements come about. So what determines whether you're accurate and or precision? So what determines whether you're accurate and or precise in a measurement? And then be able to tell from a data set if data is precise and or accurate.